Hey everybody, we're about to get started. Just hold on a few more seconds while we get everything sorted. All right, hello everybody. My name is Brian Reinhardt. I'm with Think Academy, and today I'll be giving you an overview of the MathCounts competition. This is everything that you need to know to get started with MathCounts. So before we get really started and really get going, I want to sort of tell you guys who I am and why I feel, qualified to talk about MathCounts. So I, as I said, am Brian Reinhardt, and as you can see here, I actually have gone to the MathCounts competition not just once, but twice. I went to the national competition. I went through all the different stages of the competition before that, and I met a lot of people there. So I'm, still friends with the winner from 2014, Swap Milgard, and one of my closest friends is this 13th place person, Elbert. So I really do know what I'm talking about when I'm talking about MathCounts. So in today's presentation, we're going to talk about three key topics. So the first one is, what is MathCounts? Just a general overview. What's involved in participating in MathCounts? Then the second part is going to be, who is MathCounts for? So that's going to be a bit more in depth. What do you need to know in order to do MathCounts, and sort of what are the benefits of doing MathCounts? And then lastly, how do I participate? That's how do I register? How do I get involved? And also a little bit of how do I prepare for MathCounts? So let's get moving right along with the first of those questions. So what exactly is MathCounts? Okay, well, let's look at the MathCounts website. All right, some students love math, other students fear math. MathCounts is the place for both. Okay, so MathCounts is some math thing for students who either really like math or really don't like math. Okay, and if you scroll down, it turns out MathCounts is one of three things. From right to left, because we're going to talk about the one on the far left because it's the most important. So the math video challenge is this thing where you record a video about math for the MathCounts program. It's pretty interesting, but it's more for like the video editing type if you're really into making videos. Then in the middle we have the Math Club, which is all about learning different math topics and more about the teaching part. It's giving educators the resources and guidance they need to run their math club. So that's what the Math Club is. But the most important one, and the one that I'm going to talk the most about, is the MathCounts competition series. So that's a middle school mathematics competition that builds problem-solving skills and fosters achievement through 4 levels of fun. All right, so sounds pretty interesting. Here's some just general information about MathCounts before we get into the nitty-gritty of, what's what happens in the MathCounts competition. So MathCounts, approximately 40,000 middle school students participate in MathCounts, and these include people from all 50 states as well as from some overseas territories. There's technically no strict age requirement, but you do have to be in school in 6th through 8th grade, which is the typical middle school age. And the competition consists of 3 written rounds that everybody participates in, and then 1 special countdown round for the top competitors. You can see here on the page the specifics of the MathCounts rules concerning the age requirement. So you must be in 6th through 8th grade. It also mentions at some point that you can only participate 3 times, so you can't hold yourself back a grade to participate more times and get more chances. If you're in high school, don't worry. There's lots of other math competitions. So you don't really need to participate in MathCounts anyway. But, just be aware that you're not even allowed. Okay, so let's talk about the actual structure of the MathCounts competition in terms of, how can I get to the national competition? Because that's, the really prestigious part of MathCounts. So you'll start with a school competition. The date varies. It's usually sometime in December. Sometimes it's in January. It varies a lot. It depends on which school you're going to. And then from the school competition, your school will send up to 10 people to participate in the chapter competition. You can also enroll directly in the chapter competition, but I don't recommend it. Okay, so all right, the chapter competition takes place in February. It's a little bit harder than the school competition, and if you do well enough at the chapter competition, again, it depends on which chapter, how many people get to go. But certainly, if you're on the top team or one of the top 2 individuals, you're guaranteed to qualify for the state competition, which takes place sometime in March. In the state competition, if you're on a school team, this is the big chance for your school team to show off, because only the top 4 individuals from the state competition then go to the national competition. So there's no teams progressing to the national competition. But yeah, the state competition takes place in March, and the national competition takes place usually in very early May. I should say that this is a structure for years that aren't 2020 to 2021, when there's not a virus going around and when they don't have to reschedule everything. We'll talk about what's going on this particular school year in a little bit. Okay, so what's the competition look like? Well, there's 3 written rounds, as I mentioned. The first is the sprint round, which is 30 questions in 40 minutes. You are not allowed to use a calculator, and it's 1 point per question. This round is most similar to if you've done the AMC 8. It's very similar to the AMC 8. You just do 30 questions in 40 minutes, see how many you can solve. You don't lose points for wrong answers, stuff like that. After the sprint round comes the target round. So the target round is a little bit weirder. There's 4 sets of 2 questions. So you'll get 2 questions for 6 minutes at a time, and you're allowed to use a calculator. And then after the 6 minutes are up, the person running the test will take away those 2 questions, they'll give you the next 2 questions, and that's how the target round works. The target round problems are usually harder than the sprint round problems, and they're worth more points, 2 points per question. Finally, there's the team round, which is 10 questions in 20 minutes. You work as a team, usually if you're in the chapter or the state competition, that's other people from your school, and if you're in the national competition, that's other people from your state. You're allowed to use calculators, and you get 2 team points per question answered correctly, although that doesn't actually count towards your individual score, which is what matters for the countdown round, which we'll talk about. The MathCounts website actually has sample rounds for you to look at. There will be a link in the description. But yeah. So there's also, just to give you a brief glimpse of what these rounds look like, they're just sort of test papers, Here's the first pages of the sprint round. You can see you fill out some information, and here's questions. Target round looks pretty similar, but it's only 2 questions at a time, so you only see 2 questions on that one page. And the team round, there's a third page which has the other 5 questions. All right, and then after those 3 written rounds, the top individuals compete in the final round called the countdown round. So the countdown round is this one-on-one round that emphasizes speed. You don't get to use any calculators. Somebody will read the questions out loud, and then you compete head-to-head against somebody else to see who can solve the question fastest. Technically, the max time is 45 seconds. Uh, and the rules for each individual head-to-head round vary. Sometimes it'll be, oh, we'll give you 3 questions, and whoever solves the most of those gets to move on. Sometimes it'll be, oh, we'll play until somebody answers 3 questions correctly. It depends on like if you're at the state competition or at the national competition, if you're in the 10th place versus 9th place round, or if you're in the 1st versus 2nd place round. It all varies. The national countdown round is actually really cool. It's broadcast on national television, I think on ESPN2. It's hosted by Will Wheaton, and it's recorded and posted on YouTube for the world to see. There's some of these replays of the national competition countdown round have over 1 million views on YouTube. So if you go to the national countdown round, you're going to get seen by somebody, for sure. I'll have an example link for the national countdown round, again, in the description. All right, so that was for normal years. But now we have to talk about this year, where there's a virus going around, can't hold in-person events, what's going to happen? So this time, instead of a school competition, MathCounts has these practice competitions that they've already published. And your school will like distribute them, and hypothetically they're just for practice. I imagine that some schools would use them to help determine who they're going to send to the chapter competition. So, right, the chapter competition is on February 5th and 6th. By the way, all of this is taking place entirely online, with one exception that I'll talk about. But yeah, so up to 15 members of your school will go to the chapter competition on February 5th and 6th. You can also register directly for the chapter competition. I still don't recommend it. And then if you do well enough on the chapter competition, you go to the chapter invitational competition. So that's the top student from each school and the top 20% of students from each chapter. So this bar is a lot lower than the bar for making it to the state competition normally is, which is why it's called the chapter invitational competition. So that takes place on February 25th. And if you do well enough on that, there's a much higher bar, which is the top 5 students from each chapter, plus the top 10 other students that weren't in one of those top 5s, then qualify to go to the state competition, which takes place on March 25th. So this is still all online. You do it through the Art of Problem Solving contest platform. There's a whole process. But the last thing, the national competition for the top 4 individuals from each state, they are planning to hold it in person. I imagine that they're hoping that the vaccine will be out and most people will have it by then, so it won't be as unsafe. And the national competition is scheduled for May 8th through 11th. Yeah, so the structure is mostly the same, except there's no team round. The team round is nationals only, so no working together with people from your school this year. And the countdown round is also nationals only, so that's no, they're not gonna figure out how to do the button presses and everything online because I assume there would be like lag issues. Okay, so that's the general overview of MathCounts. That's sort of everything that's really important to know about the sort of logistics of MathCounts. So the next question is, who is MathCounts for? Should I participate? And to do that, we're going to have to talk about some actual math. So first, let's talk about the difficulty of MathCounts. It varies a lot, based on which round you're in. The countdown round tends to have the easiest problems because you have the least amount of time, and the team round has the most problems because you have the hardest problems because you have the most amount of time. Also, the higher level competitions, so like nationals and state, are harder than the lower level ones, like the chapter and the school rounds. In particular, I have some comparisons here, but the school level is kind of similar in difficulty to Math Kangaroo grades 7 and 8, if you're familiar with Math Kangaroo. If you're more familiar with the AMC 8 or the AMC 10. You should know the national competition is sort of more similar in difficulty to some of the mid AMC 10 problems. And if you don't know what any of these words mean, just know it's going to be hard. It's going to be harder than anything that you've done for any class in school. In math counts in like all competition math. So that would be AMC 8 and Math Kangaroo and all this stuff. They require not just knowledge of topics, but also good intuition and problem solving skills. All right, so let's go for some direct comparisons between problems. So this is a problem from this year's AMC, or well, technically last year's, 2020's AMC 8. It's problem 21. And you can see it's about how many paths are there from the top row of this board to the bottom row of this board, from this square to that square. Well, there's a very, very similar problem from last year's MathCounts state sprint round. And it's problem 14. So that should give you some idea. Okay, these late AMC 8 problems are kind of like the mid-state sprint round problems. In contrast, if you look at the school competition, here is a 2019 practice Math Kangaroo problem from grades 7 and 8, which is all about how affecting percentages and ratios, and how does adding and changing things affect percentages. And then here's a not quite the same but slightly similar problem from the school sprint round, also about, okay, we're mixing things together, but it's about percentages and changing percentages. Okay. Let's talk a little more about difficulty. Here's just a brief comparison about the time for each problem. So in the sprint round, you have about 80 seconds per problem. In the target round, you'll have about 180 seconds per problem. So that's a lot more in the sprint round. That's 3 minutes. And the team round, so the team round's a bit harder to calculate here because you do have 10 problems in 20 minutes, but you also have all 4 team members. So hypothetically, if your team members somehow did 2.5 problems each, I guess not really how math competitions work, but if that were somehow how math competitions work, then it would be 8 minutes per problem. A more typical thing that you might be looking at is you'll have each problem is double checked. So, one person will do a problem and then another person will do the same problem to make sure that the answers are the same and to make sure that we're getting the correct answer. And so if you do that, that's still 4 minutes per problem, which is still more than the amount of time that you have on the target round. And then the countdown round is technically 45 seconds per problem, but usually you'll need to be even faster than that. You'll see, especially in the national countdown round replays, that these people are really, really, really fast at solving these problems. Like you'll see people who buzz in on these like paragraph-long problems with the answer before the person has even finished reading the problem out. So you got to be fast for the countdown round. So let's talk about some actual math knowledge, like specifics of what math do I need to know to do okay on the MathCounts competition. Well, so I've divided MathCounts problems into about 5 different categories: algebra, geometry, combinatorics, number theory, and number sense. We'll talk about what each of those categories means as they come up. So let's first talk about algebra. Algebra is, just sort of symbol pushing. What do I do when I see an x? What do I do? How do I manipulate numbers in equations? So for algebra, you'll need to know about systems of equations. You'll need to understand how polynomials work and completing the square. Some really common topics from algebra are rates and related rates, so understanding how ratios work and how to scale things. And also linear equations, so understanding, if I have y equals ax plus b, or if I have, 2x plus 3 equals 7, how do I solve a problem like that? If you've taken Algebra 1 and maybe a little bit of Algebra 2 might be necessary, but if you've taken Algebra 1, then you can probably go in and take MathCounts and you'll be fine. For geometry, there's a lot to know for geometry. You'll need to understand angles and polygons and triangles and circles, and certainly the Pythagorean theorem. You'll need to know about coordinates and how Cartesian coordinates work. Some of the most common topics you'll see in geometry have to do with triangles. You'll see a lot of triangle similarity problems and angle problems, where you'll have to like figure out, oh, I know these angles, now I have to figure out this other angle. You'll also, there's a few problems about 3D geometry, but you don't have to be like a super 3D geometry expert. You'll just have to understand like what's a volume and how do I find the volumes of certain objects. And down here is a problem that's a little bit of algebra and a little bit of geometry, which is about these Cartesian coordinates and understanding how circles work with Cartesian coordinates and tangency and other stuff. Okay. Next up, we'll talk about number theory. So number theory is sort of multiplying and dividing numbers, and how do like integers in particular work, especially like with factorization and divisibility and that kind of stuff. So you'll need to know divisibility and factorization, of course, about primes and everything. You should probably know about the Chinese remainder theorem, and about like base number systems like binary and hexadecimal stuff that isn't base 10. That's sort of the base knowledge of number theory that you'll want to make sure you have. Some common number theory topics that you'll see have to do with, so you'll see problems where you have to calculate the last digit or the last two digits of some number based on properties of other numbers. And also you'll see problems about primes and prime factorization, where it'll be like, oh, how many times does 3 divide 33 factorial? So those kinds of problems are pretty common. Hypothetically, you could do MathCounts without understanding modular arithmetic. I don't recommend it. You should have, you should know what modular arithmetic is and how to use it. And it'll get you really far in MathCounts for number theory. All right, category 4 is combinatorics. I have it here as combinatorics and probability. They're very similar. Probability is often closely related to combinatorics. Combinatorics, by the way, is about counting the number of ways that you can do something. So it'll be how many ways are there to arrange 4 people in a line if there's 2 of them that can't stand next to each other. That would be an example of a combinatorics problem. And some of the common topics that you learn about combinatorics, you learn about these in school, and you'll need to know about them for MathCounts. You need to know permutations and combinations. You need to know exponents. You need to know factorials. I didn't write that here, but you need to know factorials. And you need to know when to use each of these things and how they count various things. One of the most common things you'll see is a combinatorics problem combined with another topic, where it'll say, okay, well, let's look at the example problem I have on the slide here. We have to find the probability that this product leaves a remainder of 4 when divided by 30. Well, that requires that I understand the number theory. What does it mean to leave a remainder of 4 when divided by 30? And then do the combinatorics of, and then how many ways are there to do that? What's the probability involved? Combinatorics always requires lots of intuition, lots of I did lots of practice problems. I understand how the different combinatorics the different permutations and combinations work and how they work together. So lots of practice. Lastly, we have number sense, which is, how do numbers work when are numbers bigger than other numbers? How do I multiply things? Sounds really kind of silly, but you can get some really hard problems that just, don't have any obvious sort of categorization into these other 4 categories, where they'll be like, what's the, how many numbers have such and such first digit? It's just about understanding, how numbers work and, when they have certain properties. You can see here a really hard number sense problem from the state target round from 2020. Yeah, it's not quite as easy as it sounds. There's a few other topics that you'll see sometimes in MathCounts, like there was a problem about like liars and truth tellers on an island. So that's like a logic problem. But they're simple enough that you don't technically need any prior knowledge. You just need to understand, oh, how do I deduce things? And then for statistics, there's a few like stem and leaf plot problems, or reading a chart, reading a table problems, those kinds of things. You're not gonna have to go too in depth for either of these. I think you'll learn everything you need to know for them in your 6th or 7th grade classes. Okay. Just to give you an idea of what the different, like how often different problems appear, I went through a few old MathCounts tests and I tried to categorize them into these 5 categories, and this was the result. As I said, there were a few that were just logic problems and just reading a chart, reading a table problems, but overall, algebra is really common. Number sense also really common. Geometry, I sort of, algebra and number sense, there were some problems where it was hard to distinguish them. I would say like sort of, they're the 2 most important topics because they're like the ones that sort of, they'll appear most often, and they'll appear often mixed with the other topics, mixed with number theory and combinatorics. So you need to know them the best. Geometry is the next most common. Lots of problems, as I said, about triangles. After that, number theory and combinatorics, both, pretty much equally common. So, lastly, let's talk about the experience of what's it like to do MathCounts. I think I can speak from my own experience. So, let's start with, how did I get interested in MathCounts? Well, first, I got interested in math competitions after I took the AMC 10 in 6th grade. I didn't do so well, and I was really frustrated. And so I did a lot of practice problems online and tried to get really good. And then I wanted to do lots of math competitions. So how do you do math competitions? Well, you have to get together a MathCounts team. There was a problem. There weren't many people at my school who were interested in doing MathCounts and doing this competition. So I had to get together a few people in order to form a team, and we didn't even have a school competition because there just weren't enough people that we needed to. So we went straight to the chapter competition. I placed first out of over 100 competitors twice, both in 2013 and in 2014. I didn't participate in 6th grade because I didn't learn about math competitions until later in 6th grade when it was too late. So I met, and while I was there, I met Atticus, who I stayed in touch with for a little bit. I'm not really still in touch with him nowadays, but he was one of the other top mathletes in my area. Where I really met a lot of important people was the state competition. So I finished 2nd at the state competition twice, to both times to this guy Graham. I'm still frustrated about losing to. There's this interesting thing where the countdown round can actually make or break your position in in the rankings. So I got first place in the written rounds at the state competition, but then I was placed in the head-to-head against Graham, who destroyed me at the countdown round, and so I lost my first place spot and fell to 2nd place in 2013. While I was at the state competition, I met, again, a bunch of people, including John, who is without John, I would not have gone to any of the high school competitions that I mentioned, the HMMT, ARML, and PUMAC. And, through him, I met lots and lots of other people. I met, I mentioned Graham. I also met Richard. So these were 2 of the people who were on the Florida team. And they're like 2 of the best mathletes in Florida. They were on my team for HMMT and PUMAC in high school. Really cool guys. And then the national competition, I got 13th and 21st, 13th in 2013, 21st in 2014. I did not make the countdown round. I was very frustrated that I got 13th and did not make the countdown round by 1 spot. It was the first time that I met Swapnil and Elbert, the people that I mentioned in the beginning, and also a lot of other people. There's a lot of people on those first two slides that I didn't get the chance to mention, but I met them. I certainly could text them or call them nowadays, and they would be like, "Oh, it's Brian. Hi, Brian." So, sort of the point I'm trying to make is, MathCounts is a really good way to meet people. It might not be so good this year because of the coronavirus stuff, but you can meet people who are like performing at your level of math by doing MathCounts and going to all the different competitions. So, in summary, who is MathCounts for? Who should participate? Well, you should participate if you want to meet other mathletes who are in your area or at your level of competition, of doing math. You should participate if you want to do hard math problems with your classmates or with your friends. MathCounts is a fantastic way to do that because you'll do, first of all, there's the team round at the actual competition, but there's also lots of training that you can do through the MathCounts Math Club and through lots of other stuff that you can do with your friends. So MathCounts is good for that. MathCounts is good as opposed to the AMC 8, which I've mentioned a few times. The AMC 8 is a little bit more focused on, being, creative, like actually knowing what to do for a very difficult problem. And so it has, pretty difficult problems, but the time limit is not that bad. And so it's usually not as much about, being super fast at solving these problems. With MathCounts, you're trying to show that you're the fastest. You want to do the countdown round. You want to be super fast. You want to beat your competitors. That's what MathCounts lets you do. And lastly, if you think you're really that good, you could maybe get to that top level and meet Will Wheaton and compete on national television. There's even prizes for first place individual and first place team, but you can't count on getting those. You gotta, like, the people at the top level are all like pretty much equally competitive with each other. So I wouldn't really count on that. I would instead count on oh, I want to show things off. I want to be the best mathlete and show that I'm the best mathlete. So how do I participate? Well, we'll talk about the specifics of how do I get registered and everything in a little bit. But first, you got to talk about preparing. So I have some free resources and I have some paid resources here. For some free resources, you got to do practice problems. You got to do practice problems. There's a reason that I put practice problems in very large text here. Yeah. So if you want to prepare, this is the most important thing is you have to do practice problems. There's a free resource called Alcumus, which I'll touch on a little bit in a little bit. So, but yeah, Alcumus is a very good place to go to do practice problems. There's also this thing called For the Win, which again, I'll touch on it. I'll show you what to do and how to get involved in that. It's really good for practicing and preparing for the countdown round, for really honing your speed skills. And then for my last free resource, there's MathCounts Minis. There's a link. There will be a link in the description to. There's a playlist. There's a bunch of fantastic videos. They're called MathCounts Minis. They'll go over different topics. They'll show you how to do particularly difficult problems. They're wonderful. I recommend them very strongly. For paid resources, there's Think Academy. There's the free Think Academy YouTube channel, and there's also you can get involved in Think Academy and do their other programs. And that's of course you can get better at math by getting involved in Think Academy and taking all their classes and stuff. There's also the MathCounts Math Club. I mentioned it. Directly involved in MathCounts. And there's a book, The Art of Problem Solving Volume 1, which is a good primer for sort of the fundamentals you need to know to participate and to be one of the really good ones in MathCounts. So this slide is actually just about For the Win. So to get involved in For the Win, you'll go to the Art of Problem Solving website at artofproblemsolving.com, click Resources, and you can find it right on that resources page. So there's a bunch of different games that you can. The way it works is like you'll create a game or you'll join an existing game, and then it'll give you a problem, and you have to hit a button in order to answer the problem. And try and you're competing to be the fastest. You'll get more or less points depending on how quickly you answer. For Alcumus, similarly, you'll want to go to artofproblemsolving.com, go to resources, it's under there. Alcumus is really cool. It's basically just, a bunch of practice problems. And so you go there, and if you do Alcumus, then you can the way Alcumus works is there's lots of different focuses, and you can go there. You can do you can pick your focus based on like, oh, what topic am I really good at, or what topic am I really bad at, and have this progress bar to show how good you are. Of course, I have perfect progress on all of my different what's it called? All of my different focuses. So not really useful to look at mine, but normally it'll be like red or orange or green or blue depending on how good you are at each different topic. And then you can pick a topic to set it as your focus, and it'll give you problems in that topic. So that's really cool. That's Alcumus it's also like pretty gamey, like it feels sort of like you're playing a game when you're doing Alcumus. So it's really nice. How to register. So this is how you really like specifically get involved. For coaches and non-school affiliated individuals, you'll go to mathcounts.org. You click some buttons and fill out some forms. It's not that bad. If you're, but I really recommend that if you're at all affiliated with a school, that you register through your school. And that would be, so how do you register through your school? You talk to your math teacher. You talk to somebody who you think is going to be a good MathCounts coach, and you try and get a team set up. And math competitions, they're more fun with friends. That's sort of that's one of the key things about MathCounts, is that you meet a lot of these people who are going to be your good friends, and also they're going to do math with you in the future. So really just get involved with your school team, talk to your math teacher, and get involved that way. All right, so here's a quick summary. MathCounts is a math competition for middle school students, which has difficult problems and fast-paced settings, which encourages development of not just good problem-solving skills, but also fast problem-solving skills. MathCounts is for middle school students who are really bored in math class and want to do more interesting math problems that require creativity rather than just memorization and rote repetition. Compared to the AMC8 and other math competitions that offer similar things, MathCounts is especially notable because it doesn't just require creative problem-solving skills, it also requires you to be fast and solve problems quickly. And if you want to get involved, you should get involved with your school's existing team or form a new one. And you should prepare yourself by doing lots and lots of practice problems. And learning the tricks of the trade from these different resources, like Alcumus, like For the Win, like the Art of Problem Solving Volume 1, like Think Academy. All right, and that's all. Thank you for watching and for joining me today. If you really liked this video, please subscribe to the Think Academy YouTube channel. We'll be having more webinars like this in the future. So yeah, thank you very much.